Alright guys, we've made it to object-oriented programming. So what is an object? An object is a collection of attributes and methods. Attributes are characteristics of an object. Methods are functions of an object. So what does that mean? I'll give you some examples. They could be used to mimic real-world items, like a microwave. A microwave has attributes. It's metal, square, or maybe it's plastic. Has a door. It's like a container that you could put stuff in. And the method, which is the function of the microwave, it heats up food with radiation. You can set a time, you can set the temperature. We have another object like a fishing rod. It's a long stick with a string and a spool. And the method, the function of a fishing rod, helps you catch fish to feed your family. And these are created from classes. This means after our include input output stream, we're going to declare a class and we'll name it wizard. So you can give this whatever name you want, but I'm just going to do wizard. So this is going to be a class. We'll do public. And public is the type of attributes that can be publicly seen from outside of the class. So public information or attributes about the wizards. Wizards have names, so we can give it a name. We can give it a school. They got schools of magic for wizards. And we can give it a level. We can create our main block and then declare this wizard. So we got wizard, wizard1. So wizard1 name, we can give our wizard some kind of wizard name like Mjolnir. I don't know, I just made that up. Wizard1 school, he is in pyromancy. And then we got wizard1 level, he is level 53. So standard console output, wizard1 name, add in the school here, add in the level here. And if I hit play, it shows the wizard's name, the school of magic he's in, and his level. So far, this looks exactly like the last lesson in the last video, which was structs. This is exactly like a struct. The only difference is we use class instead of struct, and we have this thing called public in here. But there is actually one more difference, or a few more differences from structs. It's basically a struct, but a lot more expanded upon. So here we can create functions that a wizard can do. So what did wizards do? They cast spells. Wizard is casting a spell. We can create another one called drink. Wizards drink. Wizard is drinking. He's a drunk wizard. Wizards also study to learn new spells and to increase their level. Wizard is studying. And now we have these functions. All we go down here and do wizard1 spell, wizard1 drink, and study. So now if I hit play, casting a spell. And we'll add a line indentation here. So it says wizard is casting a spell, wizard is drinking, wizard is studying. So it's starting to look a little bit more like a video game, and that's why C++ is so popular for video games. Now let's talk about constructors. So a constructor is a special method that is automatically called when an object is initiated. It's useful for assigning values to attributes as arguments. So let's just delete all of these. So I can actually, instead of writing this all out here, let me comment this out. I could do this instead. Mjolnir, pyromancy, and 53. But it's not going to like this because we have to enable it up in the class. We do it with something called instantiation, where we type out the class name, and then we specify all of the different variables within it. The school and the level. And then we type in this name equals name. So within this instantiation, we're saying that this name equals the name. And then this school equals school. And we're saying this level equals level. With this written out now, it shows all of our outputs down here. Up in the class, we've specified the work. So down in the int function block, we could take this out and it looks a lot cleaner. We can replace the variable names with whatever we want, like an alias, like X, Y, and Z. Y, and Z. And then we can go ahead and just delete this. So that's actually kind of the point of using instantiation. You can make things look cleaner. You can use different variables to become aliases to represent the same thing. So within object-oriented programming, we have a few more concepts. Abstraction, which is hiding unnecessary data from outside a class. We have a getter, which is a function that makes a private attribute readable. We got a setter that makes the function writable. So a getter is like, with abstraction, you are in a room with a door you can close. So the door is the abstraction. So you could be changing or sleeping. You can't see what you're doing. So the door is the abstraction. The getter is like a peephole through the door where someone outside can read what's inside the room. So they can just like look inside the room and see everything that's in it. A setter is you give someone outside the door the key to come in your room and just start messing up your bed, turn your desk upside down, and they just completely rearrange your room or do whatever they want with it. And we'll put in a public for int temperature equals 0. We can now initiate this toaster down here. Toaster, and we'll do toaster. We'll do toaster 1. Toaster 1 temperature equals 10. Standard console output. The temperature is, and then we'll put in toaster 1 dot temperature. So now if we print this out, we get the temperature is 10. But if we want to hide this temperature variable, we could do private, which now we get a squiggly line here saying this variable is undeclared. We'll create another method, a public one, and this is a getter, so it uses get temperature. If it was a setter, we would type set temperature. And then down here we can comment this out, and we'll just do get temperature. And now if I hit play, it's getting this temperature up here, which is 0. We'll create the setter now, and we'll pass in the temperature variable. And then we'll do if temperature is less than 0, then we'll do this temperature equals 0. So we want to make a minimum. The minimum temperature on our toaster is going to be 0. So anything less than 0, like -1, we're just not even going to work with it. We're just going to say it's 0. Else if temperature is greater than or equal to 10, we're going to put in 10 as the maximum temperature. So this temperature is 10. So if I put in 100, it would max out at 10 and give us 10. Because the toaster doesn't go higher than 10. Else, the temperature is whatever the temperature is between 0 and 10. So down here, we do toaster1.setTemp. So we can put in a number here to set the temperature. We'll do 5, and if we hit play, so you know it goes from 0 to 5 because we just set it to 5. If we set it to 500, then it maxes out at 10 because the toaster doesn't go that high. The maximum is 10. And if we do, and if I go to -500, it shows temperature is 10, which it should show 0. Maybe I'll do less than or equal to. There you go. So now if it's 500, it shows as 0 because it doesn't go as low as minus 500. It goes as low as 0. Those are getters and setters. Let's talk about inheritance. For this example, we're going to do class, which is a moose. We'll create a public attribute. It'll be a Boolean, wildlife. We're checking to see if moose is a type of wildlife, which it is, so we'll do true. We'll create a method by doing void, name it eat, because moose will eat. The moose is eating. In the int block, we're going to reference moose the same way as we would to create a struct or a class. And the moose is going to check for the wildlife. And then next, we do moose.eat. We can see it's 1 because 1 shows true, 0 would be false. And it shows the moose is eating. We can create another class, call it loose. And we'll do a semicolon. We'll type in public moose. This now takes all of the public information from the moose class and allows loose to access and utilize it all. So with loose, we're going to create a method called moosen. It says the loose is on the loose. Down here, we'll do moose.moosen. And it doesn't like it because we're using the moose class, but the moose class can't see what's in the loose class. But the loose class can see what's in the moose class because the loose inherits what is in the moose class with this semicolon public moose statement right here. So the loose can see everything in the moose and do whatever's in the moose and whatever itself can do, but not vice versa. So I hope that made sense. That is what inheritance is, and I'd like to thank you for watching.